Hello everyone, welcome back. In this unit, we are going to discuss about AVL tree. Okay, AVL under that AVL tree, we are going to discuss the single rotation alone in this video. Okay, what is that AVL tree? AVL tree basically it is a kind of binary search tree with balance factor. Okay, usually the balance factor it will be calculated by using the formula balance factor is equal to height of left subtree minus height of the right subtree. Balance factor that must be either a +1 0 or -1. In these cases only the given tree will be considered as a AVL tree. Other trees are not considered as a AVL tree. The tree which we will construct by using the binary tree concept with binary search tree properties. Already we know that binary tree is a tree. In this each root node can have a two children nodes, or we can say that node no node can have more than two children. It is called as a binary tree. Then the binary search tree, it is a kind of search tree which is used to search the elements from the binary search tree. While we are constructing a binary search tree, the property says that if the given x element is lesser than the root node, then we have to travel in the left side and we have to find out the appropriate place, we have to insert it. If it is greater than, then we have to travel in the right side, have to find out the appropriate place and we have to look place it values. Okay, in similar way here also we will construct the tree. Okay, the first tree it is a it is a binary AVL tree, and the second one is it is not a AVL tree. Okay, because the value which is lesser than it is placed in the right side, greater than is placed in the left side. Okay, can you guess why we need a AVL tree? If you insert the values from 1 to 7, okay, if you first insert 1, the next value is 2, we have to compare with the 1, it is greater than, it will be placed in the right side. Next is 3 4 5 6 7, everything it is coming in an increasing order, so all the element it will be kept placed in the right side alone. So if we insert this in this way, then our tree will become imbalanced. Okay, and this one second one is, this one is the binary tree. In this the root node is 4 is having the 2 and 5 are the 6 are the two child node for this 4, and here 1 and 3 is the child for 2. Okay, here also it's same applies. So it is a binary tree, and second one is the AVL tree. Okay, while we are coming to this, the height of the AVL tree it is large. Okay, if you go in this way, then our tree is imbalanced. The searching, insertion, deletion, everything it will be creates a complex problem. So avoid all those complications, the AVL tree is constructed. AVL tree actually it is constructed by Adolphson, Welskill and Landis. 3 persons were joined togetherly and finded this tree. Okay, the AVL tree it is a height balanced binary search tree, and the next one is already we have discussed that the balance factor, and the every node it will maintain the extra information that is known as the balance factors. The balance factor is calculated by using the formula height of left subtree minus height of right subtree. Every AVL tree is a binary search tree, but every binary search tree need not to be a AVL tree. Okay, the operations which is performed in this AVL tree are insertion, deletion, okay, and search operations. Here you can consider this tree. In this the values which is placed 0 1, okay, that is the balance factor. Okay, the balance factors are calculated by using this formula. Using this formula, it is being calculated. Okay, then if in second slide we have seen that the values which we have inserted 1 to 7, everything it is going on the right side. Okay, while we are inserting like that, the tree is become imbalanced. So that particular trees are balanced by using this 4 rotations: LL rotation, RR rotation, LR rotation, and RL rotations. These four are the four types of rotations which is used to fix the unbalanced conditions to become a balanced one. Okay, first we will discuss the single rotation. The single rotation is used to fix the case 1 and case 2, left LL rotation and RR rotations. For that, the general representation of tree is will be like this. Okay, the root node will be there, then the left child, and the inserting in the left child. Okay, root, left child we are going to insert. In this case, our tree will become imbalanced. Okay, so that time what we have to do, we have to do a right rotations. So if we rotate that, then x will be placed in the immediate left of the root node. In this way we can avoid the problem. Okay. Here the LL rotation it is given. If it is a LL rotation, we have to rotate the tree right. Okay, if RR, then we have to rotate tree in left. Here, if I am inserting, consider this tree 3, 2, 1. Okay, in this we are inserting the 1 tree. Okay, in this time other balance factor, or we have to calculate the balance factor 0, 1, 2. The balance factor should be +1, 0, or -1. In that case, first we have to fix the k1, k2, then we have to do a rotation. Okay, in this one only we are going to insert. The k2 will be 2 and 3, and k1 will be 2. The k1 should be come to the root node. If you look at this diagram, the 2 will become a root node, 1 is in left and 3 is in right side. Okay, like that for RR relationship. If we are going to the RR rotations, the left rotation should be taken place. You can consider this diagram. The value is -2. In this case also we have to fix the k1 and k2. In this case, k2 should be in root node, then x and y will be in the left and right. Okay, you can consider this example. First case 1, what I am going to do, I am going to insert 1. Okay, before inserting, first we have to calculate the balance factor. The leaf node usually is 0. While you are coming to 5, height of left subtree minus height of right subtree, 1 minus 1 is 0. And while you are coming to the root node, here there are 2 levels are there. This side only 1 level, so 2 minus 1 is 1. Now next what we are going to do, we are going to insert 1. If I am going to insert 1, it will be inserted in the left side. Okay, left subtree, then again left subtree, then again left side child we have inserted. If we insert like this, then the tree will become imbalanced. Here the value will become 2. Okay, in this case, first we have to fix the k1, k2 and x, y, z. After that we have to do a rotation, right rotation. Here after performing the right rotations, if you perform right rotation, the 5 will become a root node, then 8 will come to the immediate right, and the 7, it is in the 5 right side, it will be attached in the left side of 8. Okay, now the tree is will become a balanced. And next case is in order have given us case 2. Okay, for that also the example is given. In this example, I am going to insert 10. If I insert 10 here, the tree will become imbalanced. So here also we have to fix the k1 and k2. After fixing the k1 and k2, we have to rotate it. In this case, the k1 will become a root node. Then this is the routine. routine for the single rotation with lift. First we have to identify the position K1, then we have to assign the K2 left to K1, then K1 right will be attached to the K2 left, that's 7 value 7, okay. Then K2 will be assigned to a K1 right. Then after that we have to find out the balance factor. The balance factor for finding that we have to use this equation. Okay. This is the another example. And this is the routine for RR rotations. The same thing in previous left rotation LL we have to find out the K1. Here we have to find out the K2. Okay. Reference. Thank you.